space vector is okay now. It is motivated from rotating machine. Now it is applied at everywhere where even machine is not there. Okay, but concept is being utilized. So if you put this theta e is equal to omega t plus theta e naught. Theta e naught is the initial value of that angle at t is equal to 0. What is the angle? If you put in the above equation, you will get this x vector, space vector is equal to xm e j omega t plus theta, this theta e naught. Okay. It can be decomposed into two axes, real part and imaginary part. Real part will give you alpha component and imaginary part will give you beta component. But yeah, remember alpha is this side, beta is this side. Okay, plus 90 degree. This is known as Clark transformation. Now I want to see the same space vector from a frame which is rotating at theta r, where theta r is equal to omega r t plus theta r naught. At t is equal to 0, the space the position of the reference frame is at j theta e minus theta r. What I am trying to explain you all, if you are putting omega is equal to omega r, irrespective of theta, initial theta, theta e naught or theta r naught, you are going to get DC signals. If omega is equal to omega r, there is no time varying component now. So both are DC. But it is not useful information when it comes to inverter control, grid connected converter controller control, converter control. The important information is, I will let you know, if you are choosing theta r naught is equal to theta e naught, and if you are choosing theta r naught is equal to theta e naught plus minus pi by 2, you are getting something specific. Suppose if theta r omega is equal to omega, that is true because you are in synchronous reference frame. Now you are choosing theta r naught to be equal to theta e naught. If it is so, then what is the condition? Xd is equal to xm. So xd is equal to xm, xq is going to be 0. Real part only, right? So here xd is equal to actually real part and xq is the imaginary part. So xd is going to be xm, xq is equal to be 0. Similarly, apply for the second one. If it is at plus minus pi by 2, suppose plus pi by 2, theta r is equal to theta e naught plus pi by 2, then this theta r naught minus theta e naught is going to be pi by 2, then real component is not there. So Vd is 0, Vq is the peak value of that. So one of the component is becoming 0, either Vd, Xd or Xq, depending on the two choices, theta is equal to theta naught, theta e naught or plus minus pi by 2. This is very important information and it is actually used in, I mentioned the applications, voltage oriented control, UPS, grid connected converter, everywhere. The reason behind this is, I will come back to those slides. The reason is this only. In space vector format, the complex power is given as 3 by 2 times V vector and I vector. If you put V vector is equal to Vd plus jVq, I vector is equal to Id plus jiq, you take the complex conjugate, you do the this multiplication, and you take real and imaginary part, you will get active power to be 3 by 2 Vd Id plus Vq Iq and reactive power to be Vq Id minus Vd Iq 3 by 2 times. If one of the component is becoming 0, either Vd or Vq, depends on your choice where you are putting your reference frame. If one is becoming 0, then P becomes 3 by 2. If I am assuming that Vq is going to be 0, then P is equal to 3 by 2 VD ID, and Q is going to be minus 3 by 2 VD IQ. VD is common in both equations. So you can control active power exclusively by controlling ID, and you can control reactive power exclusively by IQ. So this condition, whether theta r E naught, theta r naught is equal to theta E naught, or this plus minus pi by 2, that gives you power decoupling. If suppose this is angle is pi by 4, then both components are there, VD is there, VQ is there. You cannot do decoupling, that okay, reactive power, to change the reactive power you change IQ, to change active power you change ID. This will not be possible if one of the component is not 0. Making sense? Okay. I don't know how many of you have tried this transformation using this MATLAB on Simulink, using block. Have you used ABC to DQ block, DQ0 block? Yes. Okay. When you double clicked over that, you have two options. D axis aligning A phase axis, D is 90 degree behind. So that actually position of the reference frame where you want to put A पे या A से 90 degree नीचे. 90 degree नीचे क्यों दिया? I have some logic behind that. Okay, this is how space vector, the rotating magnetic field was created. That 3 windings are there, A dash, B dash, C dash. 3 phase signals is provided, excited, and a rotating vector was formed. At t is equal to 0, if you see, and I am assuming, taking assumption that when current will be positive, it will be entering A, I am talking about A phase, it will be entering A and leaving A dash if it is positive. If it is negative, then it will be entering A dash and leaving A. Same valid for B phase and C phase. Okay, this is what assumption is. At t is equal to 0, A is 0, A phase is 0, B and C are equal but opposite magnitude. So B is positive and C is negative, and A is 0. So if A is not there, then A winding will not be contributing anything to the resultant magnetic vector. But B is negative, it means current will be entering at B dash and coming out of B, because B is negative. C is positive, so same, it will be entering at C and leaving out from C dash. So this cross and dot are made according to that. And if you apply this right hand rule, you will find this rotating vector position is just 90 degree from the A phase, and it is behind. So at t is equal to 0, the position of rotating vector is 90 degree behind A phase. Okay. Now I have some questions, and you are actually decomposing this vector only in D and Q. Okay. Now I have questions for you. Case 1, I have not written case 1, but it's okay from that side. The placement of axis is D axis is aligning with A phase axis, and Q axis obviously perpendicular to that. And you know that at t is equal to 0, position of space vector is 90 degree behind the phase axis. What will be the VD component and VQ component? VD will be 0 and VQ will be minus of that peak tip. Agree? Second case. Now you have shifted 45 degree. Which component will be 0? No one. Okay, both are there and both are negative and equal. Case number 3. You have used you have placed your D axis 90 degree behind the A phase axis. What will be D? What will be Q? D will be 0? VQ. VQ will be 0. VD will be positive peak of the voltage. Positive peak of the voltage. In the second last case, I have simply drawn, you will never see this case. 180 degree aligned from A phase. But okay, VD will be 0 and VQ will be positive peak of the voltage. The same thing, whatever mathematics I have explained to you, I will write in the code, and I want to verify the results which are discussed among us, that this should be. Okay? In real life applications, Chandrasekharan sir work is all about PLL only. He has done very good work in PLL. So PLL is actually used to find this theta information, which is to be utilized in ABC to DQ transformation. So PLL work is to get this theta information. For my purpose, I have made theta. Otherwise, if I am working with external circuit, I have to sense the signal, I have to use PLL, then I will get theta, then I will use in my converter for ABC to DQ transformation. Okay. So this is the simulation data. 3 voltage signals are there, 3 phase. The peak value is going to be 440 by root 3, which is phase voltage, and peak value root 2 times. Omega obviously 2 pi into 50. Theta E naught I am assuming to be 0, and rotating speed is same, synchronous speed, and theta R naught I will change the position. And first I will assume 0, then pi by 4, then plus minus pi by 2 somehow, and I want to match the which you have told me. Then decoupling, I want to see whether decoupling is there or not. So now I will go to simulation. Since I am generating 3 phase signals through in coding itself, so I need to have some reference of time. Okay, yes. So I need to have some reference for time. So I have used one signal clock. It is there in MATLAB Simulink. And it is hanging. Yeah, I can see it. MacBook hang कर रहा है. हाँ. have taken this is MATLAB function. It is there in the, then you will click in the MATLAB and you go to Simlink, you double click there and search MATLAB function, user defined function, you will get it. So I am taking this t as a input for time reference. Omega is equal to 100 pi, this is 2 pi into 50, and I am generating, I have taken peak value 240 into square. 240 is the phase voltage RMS, then peak value will be 240 into root 2. Then I am making VA, VB, VC. So VA is Vm sin omega t, VB omega t minus 2 pi by 3, then omega t plus 2 pi by 3 or minus 4 pi by 3. Okay. Now space vector, V vector. How it was defined? 2 by 3 times of xa e power j0 plus xb j 2 pi by 3, then minus 2 pi by 3 or 4 pi by 3. The same is written, right? Can you verify? Okay. Now I have written this, I can disconnect it, don't see this, I will discuss later. I have taken theta for dq frame. Theta is going to be omega t. So same as the phase A. For phase A sin omega t, so I am using that omega t for my angle of rotation. So it is synchronous and it is aligned with phase A. So theta r naught is equal to 0, theta r naught is equal to theta e naught. Okay. Clark transformation. V alpha is going to be what? Real part of B vector and V beta imaginary part of B vector. I have included these variables V alpha, V beta at the output so that we can see on the scope these signals. For Park transformation, what to be done? First of all, the vector V vac, it is to be retarded, the speed is to be reduced by theta r. So one exponential term is multiplied minus theta minus j theta, it is multiplied in the equation. Then Vd is real part of Vdq vac, Vdq, and Vq is imaginary part of Vd. Okay. हाँ वो बोले if होगा वहाँ पे ऐसा. हाँ I actually I did for this for some purpose. Oh. Please remember the concept. The position of the reference frame is D is aligning with A and Q is perpendicular to that, and initial position of the rotating vector is going to be 90 degree behind the phase A. What do you think? A should be 0, VD should be 0, VQ should be. Can you see something negative of the peak, pink line? And 1 0 green, light green. So light green is VD and this pink is VQ. This is alpha beta, not making any difference. if you want to change something. I am shifting this reference frame to pi by 4 from the A phase, pi by 4. What do you think? Calculation says both will be non-zero, both will be equal, both will be negative. Correct? Okay, let's see the magic. ओवरलैप है, बोथ विल बी नेगेटिव. ओके, इसमें मज़ा नहीं आया, दोबारा करते हैं, एंगल चेंज कर देते हैं, पाई बाई 3 कर देते हैं. अभी भी नेगेटिव रहेंगे बट या दैट विल बी डिफरेंट. बोथ आर नेगेटिव but different magnitude. Okay, let's keep 90 degree. Plus pi by 2. What do you think? BQ, BD negative होगा. BD will be negative. Negative of the peak, BD, and VQ will be 0. Agree? Please think and converge to a particular point. BD 0? No. What is the situation? Plus 90 degree means, no, plus 90 is not there, minus 90 is there. Plus 90 means D is here and Q is here, this way. So VD will be minus of this and VQ will be 0. Let's verify. The green one was belonging to D. Pink one was Q. Now Q should be 0, so pink one should be 0, and and that green one should be negative peak. No, negative, because D is upward. In a space vector position is downward. That's why. Verifying the concept. One of the component 0. Put minus 90. Now VD will be positive peak and VQ will be 0. The objective of this tutorial was to understand what is the basics of ABC to alpha beta, ABC to DQ. What is synchronous reference frame? Even if I am not rotating this reference frame with the same speed, what will happen? I have taken this omega, theta is omega t omega. I mean omega is equal to the signal frequency, right? I am dividing it, I am multiplying by 0.5 times. Now actually signal is rotating at 50 Hertz and my reference frame is rotating at 25 Hertz. So what do you think? The reference, the signal DQ, that will be DC or AC? AC, very good. AC means what frequency they should have? 25, because 25 at 25 you are rotating, correct? So as of now you are getting constant. Now you should see AC quantities. It is AC actually. Let me do one thing. Yes, not removed. So upper to alpha beta, but this frequency you can clearly see it is half. Increase the speed, this will widen, and when it becomes equal to that speed, it becomes flat DC. Making sense? Very good. If there is circuit in grid connected converters, we align our PLL such that it will give you phase A information. So depending on your reference frame, you are assuming Q up or down. It is a very flexible system, but you should be very consistent whatever notations you have taken. If you have taken D here, Q here, okay, go with that. If you have taken D here, Q here, go for that. But you should have consistency then throughout your work. There is no issue. There is no, any implication that you need to use this only. You can use anything. If there is some circuit is there, and you have aligned your theta according to, so that VD is 0 and VQ is peak of the voltage, and you are changing active and reactive power, you will see there is change in only one current. If you are changing active power, there will be change in particular current only, second current will be undisturbed. If you are charging reactive power, the second one will be having change, the first one will not have any change. If you write this equation in matrix form, do we have time? I can go. Okay. If you write this PQ equation in matrix form, so it will be PQ, then matrix, then VD VQ, then VQ minus VD, and second column ID IQ. Are you getting? Or should I write? I don't know how to write. It's okay, na? Matrix. This is only. No. Yes, VD VQ will be forming 1 2 by 2 matrix, and then ID IQ, and here PQ. Okay. If you take inverse of that matrix, then ID IQ can be calculated from PQ utilizing this VD matrix. Okay. The same I tried to wrote in this. See, ID is equals to 2 by 3, because 3 by 2 is there, 2 by 3 will be there, and then the determinant of the matrix, which will be minus of VD square plus VQ square. So it will be, for inverse application, it is 1 upon determinant. So this is minus 1 upon VD square plus VQ square. And then for 2 by 2 matrix, what is the inverse? We all are most of them gate qualified. Yeah, in dono change, you should change the position, and then change the. Okay. So have I put same? Correct. So this will be minus VDP ref plus VQ Q ref. What do you think? It is going to be same or something? You do it now on your copy. You have pen paper. Tell me inverse. What is the inverse? Huh? Now I have doubt actually. I want you people to confirm, please. हाँ योगेश कंफर्म करना. और give me my tab also. Tab then. मुझे लगता है मैंने गलत लिखा है. Okay, one mistake. Diagonals are multiplied by -1, and this diagonal component are just replaced, exchange, right? Okay, so there is mistake. Here it should be minus, and this should be minus and plus. That is okay. I am taking IDIQ as output variable. Sir, I mean you need to confirm, okay? First we will discuss what should be the answer, then I will run the simulation and will check whether it is justifying or not. It's not like I will simulate and I will run, then I will ask that how it is happening. No, you will tell me because you know you are master of this. I have chosen this theta to be omega t. It means D is aligned phase A. Which component will be 0? Vd will be 0, Vq will be negative of peak. Okay, now you recall the power equations. So which current component is related to P and which current component is related to Q if Vd is 0? This is why it is said that please write the equations when it is shown. If Vd is 0, then P is actually related to IQ and Q is related to ID, because Vq is going to be constant for supply. If assuming supply is constant, then Vq is going to be constant. Okay. So Vq is going to be negative, right? Negative peak. Vq, negative peak. So for positive power, IQ should be negative. Okay. I have given P reference to be 10 kilowatt, Q reference to be 0. Which component will be 0? D component of the current. Q component will be there, which will be negative. What value should have you can calculate, but it's okay. I don't know why it becomes so small. What is the command for running this Simulink? No, this will run this. I don't know why it is misbehaving. Yeah, I will complain. You know, but you intentionally asking, right? Is it Apple? हाँ फिर से करना पड़ेगा. I've changed. Yeah, I've changed. Okay, I'm running. But this is voltage. I need to connect it. Yellow one is ID, blue one is IQ. ID is 0, it should be, because Q is 0. And IQ is having some magnitude. Now I am doing reverse. I am making P0 Q 10,000. Now D becomes negative, this becomes 0. I have written this if correctly. I don't know why this is coming. I want to give a condition that if time is less than 0.05, use this value and that value so that we can combinedly see that whether which component is being affected. So if it is written correctly, na? If it is. Acha, okay. No, I want to make it this only. I want to change this 5,000. Oh, that's why there is no change seen. Thank you, Yogis. Yes. At t is equal to 0.05, I should show you code. At t is equal to 0.05, when t is less than this time, P reference is 10,000, 10 kilowatt and Q is 0. After this 0.05, P reference remains same, but Q is changed to 5 kVAR. Okay. So ideally there is no change in P, there is only change in Q. So if it is proper decoupling, because you have aligned such a way that one component is going to be 0, Vd in this case Vd is going to be 0. So that's why there is no change seen when reactive power is changing. There is no change in Id. Correct? You can see. This is blue one is undisturbed. जब इतना कर ही लिया तो एक और कर लेते हैं. But I told you that this decoupling is only possible when you are making the one component for 0. Suppose this is pi by 4. You have aligned your reference frame at 45 degree. You know that Vd is going to be there, Vq is going to be there. Then decoupling is not at all possible. If you are changing active and reactive power, it will affect both. It is affecting both. So this is how you cannot control very effectively. If both currents are changing, then what was the bad about ABC frame? In AC current, you cannot see which portion is responsible for active power, which portion is reactive power. Here in DQ, you can clearly say, according to your transformer, whatever you have chosen, that ID is responsible for reactive power and IQ is responsible for reactive power. That's why voltage oriented control is very, very useful. This transformation is important, but the placement of reference frame is much more important, where you are placing that. Okay. So I hope you got it. If you have any doubt, you please ask. But when you are leaving this place, reference frame should be very okay for you, because that is going to be used by Professor Karimi for sure. I have seen the content he shown. Without that, it is not possible, because he is not going to use PR controller. He may introduce PR controller, but ultimately he will use a DQ frame and then PI controller. So for that. Okay, thank you. You ask if anything is needed then. You need to retune your PLL, because ultimately you are not aligning, PLL is aligning. If PLL is misbehaving, you identify what is the problem with PLL. Resonant is not used. If you are not at all using